Hello, my name is Germán Corrales. I'm an external associate professor with Albert University, in particular in the connectivity section. And today we have the opportunity to talk about some considerations for selecting your communication module for your IoT system or IoT device. This presentation is meant to be from a practical point of view, and the idea is to give you the basic understanding of the technologies very briefly, so then you can do some research on your own and understand better what is the different aspect you're looking at. So you can do a right comparison between technologies and be aware of the implications. So when we talk about wireless networks, the first thing that we need to take into account is, are we going to use the unlicensed spectrum or the licensed spectrum? In the licensed spectrum, like for example in LoRa, or this is also what happens every time we're using Wi-Fi, is meant for everybody. You of course need to follow certain rules, but there is no control over what's happening in that part of the spectrum. So that means that what is working today might not be working 1 year from now because sadly there are many more devices in the area. The nice thing about the licensed spectrum is that you could potentially deploy your own system without paying anybody else. So this is very interesting from a cost point of view. The other option we have is the licensed spectrum, and this is what we use every day, maybe without realizing, is when we are using our mobile phone and it's connected to our mobile operator. This is using a licensed spectrum. That means that the mobile operator is paying to the government to use a part of the spectrum that nobody else can use. And that means that they have full control over the what's happening. So if there is an interference, they can react and say, hey, this part of the spectrum is mine, you are not allowed to use it. So now we are going to take a look into a quick peek into not all of these technologies, but the main technologies, and then we will do a comparison, a quick comparison between all of them. But before I start with the license and license spectrum options, let's first take a look at this technology map, because this is another aspect that needs to be taken into account when decide what technology to use. Is depending in which country you are or in which country you want to deploy your solution, you need to take into account what options are available and which ones are more popular and less popular. So for example, if you're in Asia, NB-IoT is an extremely popular protocol. If we look into, for example, into Korea, there LoRa is extremely popular and has a very high coverage, so it makes things very easy. The same way, if you are, for example, in Europe and you are especially located in the area close to France or in France itself, Sigfox is extremely popular and have a very high coverage, so it makes things again very easy. If you are in the US, maybe you want to use LTM. This doesn't mean that these are the only options. This means that these are the most popular and it can become easier. But you can, of course, use LTM, for example, in Europe without any issue. So a licensed spectrum, one of perhaps more popular technologies today for the communication part is LoRa and also LoRaWAN. The difference is one is just a physical layer, when the other one is also taking into account the rest of the protocol, like security, authentication, MAC layer, and so on. And how does it work? Is you have your IoT devices, could be for example some sensors, that they are sending the data to a concentrator. And this concentrator is something that you can locate, for example, in your company building, and it's giving coverage to a certain area. It's typically 1-2 kilometers in urban areas. This changes depending on the topography and especially in how many buildings you have around. But then you need to take the data from this concentrator to the cloud. And if you are in the building, then of course you can just connect an Ethernet port, right? But in other locations, you might still need to use, for example, a cellular network, in this case LTE, but it could be 3G, it could be 5G, different options. So actually LoRa and cellular networks, they typically come hand by hand. So for the sensors part, you only use LoRa, but then to take the information back to the cloud, you use the cellular network. There are some highlights I put here on this table that you can take a look. I invite you to pause the video and look into it before continue with the rest of the video. But basically, I can highlight that the payload size is small, it's up to 255 bytes, and that we are using the 900 megahertz frequency. You also have here the data rate. But this means that these are meant to be for low rate type of applications. So trying to use video surveillance with LoRa might be a big challenge. Then you have Sigfox, which is still part of the license spectrum. But in here, what is happening is that the sensors or the devices are connected straight to a Sigfox base station. And a single base station in Sigfox can actually cover up to 40 kilometers, always depending on the topography. And that means that with a very few base stations, you can cover an entire city. What's the challenge for Sigfox is especially in the downlink. It's really meant to be the data coming from the sensors to the network, not the other way around. That's where you have also a limited number of messages you can send. So this might constrain you to grow your application into the future. When we look into now jumping to the license spectrum, this is cellular networks. Cellular networks deployment is very similar to what we just saw for Sigfox. You have the devices, the sensors that they connect directly to the cellular network, to the base station, and this is connected directly to the internet. And within the cellular networks, we need to make a distinction between the legacy options. This is what has been there for many years. For example, GSM, the good old GSM, worldwide coverage, extremely popular technology, probably one of the most popular technologies in the entire world. But we need to take into account that this technology is very old. So it's actually a deprecated technology. You have that the mobile operators are trying to shut down their GSM networks. So probably it's not the best decision to try to use GSM in today, because you know that it might not be there in a few years from now. But in some countries, it's still very popular. Finally, we have what we can say LTE. That is the 4G. This is the one that we use every day with our cell phones. You might have noticed that I actually skipped the 3G network. And this is because, under my point of view, 3G is not really meant for IoT devices. So you can do it, but for that you have better options. You can use LTE, or you can use also the newer version of LTE that I will show in the next slide. LTE has some special versions for IoT, which reduce the cost and the complexity. It's very popular. You have very good coverage, but the power saving and the cost is not as good as the one I will just show you a bit later in the next slide. What are the new options? So these are technologies that they started to be deployed a couple of years ago. Is again the same deployment type. You have the sensors connected to the cellular network, but the cellular network is now optimized for the Internet of Things. So that's why we have what's called the extended coverage GSM, which is basically an evolution of GSM but with additional coverage, which is a very important characteristic, and better power saving. But this is a technology that, at least in my opinion, is not very popular in most of the developed countries. This is more interesting for some places, like for example in Africa, where the 4G network is not really mature. That's where you have a nice opportunity. And maybe also in China, there are some opportunities around extended coverage GSM. But then we have the most two popular technologies today that they are being backed by very important players. I'm talking about mobile operators like the AT&T, Vodafone, Deutsche Telekom, Movistar, all the big main operators worldwide are betting for these technologies. And you also have other companies like, for example, Ericsson, Nokia, Huawei, that are also investing in this technology. So in here you have LTE-M, which means LTE for machines, and it has a reduced bandwidth, 1.4 megahertz. It's cheaper than a traditional LTE module. Has a lot of potential because it has somehow a good data rate. You can even have VoLTE is coming, but its battery consumption is, if you are battery driven, it's a problem because it requires more energy and of course the cost. Then we have NB-IoT, which is a technology specifically designed for the small Internet of Things, especially the ones that they are connected to a battery and they cannot be easily replaced. For example, a smart meter. and they have a very low power consumption, especially in the low power mode, where they can consume, for example, just 5 microamps. It depends on the communication, exact communication model you use, but generally speaking, they have those numbers. And they are able to live, to stay functioning for up to 10 years with just a couple of AA batteries. The bad thing about MB-IoT is that this mobility is not, there is no mobility. You can move the IoT device from one place to the other, but it will need to reestablish the connection. So it's not meant to be like, for example, in a car. For a car, you might want to consider 4G, or the typical LTE, or most likely LTM will be a better choice for you, at least in the cellular network part. So with this, we come to the end of this small talk about the technologies for wireless IoT. And I will not go into all the details in this table. Again, I invite you to pause the video and look at the different aspects. Here you have the frequency. You need to take into account that the higher the frequency, the lower coverage will be, because it's more difficult for the signal to reach. But all these technologies, with the exception of the standard LTE, you are able to, for example, place your IoT device in a basement and expect a relative good coverage. You have data rate, as you can see, cellular LTM is the one that has the higher data rate, but it also has higher power consumption that needs to take into account. And another important aspect is that the price for the module, the communication module, you can see that the cellular network is still more expensive in general terms than, for example, the LoRa or the Sigfox, but the price is going down. And between LTN and NB-IoT, LTM is more expensive than narrowband IoT, but it's less expensive than a typical LTE model. Still in the middle. Thank you for your attention and have a good day.